Hello everyone, welcome back to my coding days. I'm Mohammed and in today's video we will be talking about variables in C++. We will not only cover the basics of variables but also discuss some best practices and tips to write better C++ code. Let's start by understanding what a variable is in C++. A variable provides us with name storage that our programs can manipulate. Each variable in C++ has a type, which determines its size, memory layout, range of values it can hold, and the set of operations applicable to it. A variable definition in C++ consists of a type specifier followed by one or more variable names separated by commas. It ends with a semicolon. We can optionally provide an initial value for the variables. Let me show you in an example. Let me first include IOString. Then let's define the main function, which returns 0. And let's define some variables with initial value. I'm going to define an integer variable. I'm going to give it a name age, and I'm going to give it an initial value of 32. And let's define another variable of type double, and let's give it a name weight, and let's give it a value of 75.6. And we can define another variable of type char. Let's give it a name of gender, and let's give it an initial value of n. We can define other variable of bool. Let's give it a name is student, and an initial value of true. We can print out the values of variables. To do that, I'm going to use std_cout, and I will use endl to go to the next line. Let's duplicate these and modify them. And let's do it for gender. And for these students. Okay, let's build this and run clear. And we can see the value of the variables here. In C++, you may hear the term variable and object used interchangeably by programmers. An object in general is a region of memory that can contain data and has a type. In this video, we'll use the term object to refer to a region of memory with a type. Now, let's talk about variable initialization. An object that is initialized gets a specified value at the moment it is created. The value used for initialization can be a complex expression. In this example, we didn't use any complex expression to initialize these variables. We just used some literals to initialize the variables that we created. But we can use any complex expressions that we want. Let me show you in an example. Let me define two integer variables and initialize them with number. As I said before, we can when we are creating variable, we can separate them by comma and define them like this, but this is not a good practice. I usually prefer to define a variable at a separate line like this, and let's initialize a variable with a complex expression. Let's give it a name of result, and we can use any complex expression that we want here. Like this, and then let me print out the result. Build and run. There we go. In this example, we have two variables x and y, both initialized with literal values 5 and 10 respectively. Then we created another variable called result, which is initialized with a complex expression. This expression involves arithmetic operations using the values of x and y. When the program runs, it will calculate the value of the complex expression and print the result. C++ provides several forms of initialization. One of them is list initialization, which uses curly braces to initialize variables. This form is more general and flexible, but we need to be cautious with built-in types. Let's look at an example. Here I'm going to let me define the main function. I'm going to define a double variable, and let's call it double var with a value of 3.14. Then if I create an integer variable, and let's call it a, and try to initialize it with curly braces and give the double variable to it, it's going to give it an error when it is compiling. Conversion from double to int requires a narrowing conversion. So these curly braces will check if this is a legal conversion or not. However, if I use the equal sign for initialization, this will be no problem, and the value of double var will be truncated to 3 and will be stored in A. Let me demonstrate this by printing the value of A. Of course, I need to include a string, and let me run. Yeah, you can see that the value of A is 3. When a variable is defined without an explicit initializer, it undergoes default initialization. The default value depends on the type and sometimes on the variable's location. It's always a good practice to provide initializers to avoid using variables with undefined values. Let me demonstrate in an example how the default initializer works. Here I'm going to define a global variable, a variable which is defined outside of main function is a global variable. And I'm not going to initialize it to explicitly, so the default initializer will initialize the value of this variable. And also I'm going to create a local variable in the main function without initialization. And let's print these and find out what is the value of these variables. Global variable, and here global var std, and to go to the end and the next line. Let me duplicate this and local variable. Okay, let's build and run. You can see that I'm getting a warning of uninitialized local variable, but let's see why we are getting that warning. You can see that the value of the global variable is 0. It means that the default initializer has initialized it to 0, but we have something random for the local variable. So it's always a good practice to initialize variables to avoid undefined behavior. In this example, we have two variables, global variable and local variable. Both variables are declared without explicit initializers, which means they undergo default initialization. The default value assigned to these variables depends on their type and location. For global variables like global var, the default initialization sets the variable to 0 if it is of a numeric type. The global variables are stored in the static storage area and are automatically initialized to 0 by the C++ runtime. For local variables like local var, the default initialization does not provide a specific default value. So the value of local var will be whatever happens to be present in the memory location where it's allocated, which could be garbage or any random value. So local variables are stored in the stack and are not automatically initialized by the C++ runtime. Now let's talk about the scope of a name in C++. A scope is a part of the program where a name has a particular meaning. Most scopes in C++ are delimited by curly braces. Names declared in an outer scope can be accessed by inner scopes. Let me show this in an example. If let me define a variable here, get a name, and let me create an inner scope by curly braces and create other variable y. The variables in the outer scope can be accessed inside the inner scope. Let's try. Okay. However, the variables of inner scope cannot be accessed outside of their scope. So if I paste this here, I will get an error that identifier y is undefined. So the program does not know what is y because it's inside the inner scope. In C++, we are allowed to hide the name of a variable of outside a scope in an inner scope. like this. I'm allowed to define a variable called x and give it a let's give it an initial value of -10. This is called variable shadowing, but this is not a good practice and this should be avoided. Now that we have covered the fundamentals, let's talk about some good practices and tips when working with variables in C++. The first tip is that always initialize your variables. Leaving a variable uninitialized can lead to undefined behavior and difficult to debug errors. Providing an initial value ensures that your variables start with a known state. The second tip is that define variables as close as possible to where you first use them. This improves code readability and makes it easier to find the variable's definition when scanning through the code. Let me show this in an example. In this example, the variables num1 and num2 and sum are defined at the beginning of the main function. This is a common but less readable practice, especially when the function is long or when multiple variables are involved. Now let's improve this code by defining the variables as close as they are required. So num1 is used here, so it should be defined near to where it is used. Num2 is first defined here, so a good practice is to define it right before it is used. And sum is used here. So let's move sum where it is used first. So this is a good practice. The third tip is to use meaningful and descriptive variable names. Avoid single letters like X, A, B for variable names or cryptic abbreviations. This enhances code readability and makes your intentions clear for other developers. The fourth tip is to avoid variable shadowing. Be cautious with variable shadowing. While it is allowed in C++, it can lead to confusion and bugs. Try to use different names for variables to avoid unintentionally hiding variables in outer scope. The fifth tip is to limit variable scope. Minimize the scope of your variable whenever possible. Variables with smaller scopes are easier to manage and reduce the risk of accidental misuse. That's it for this video on variables in C++. I hope you found it helpful and gained a better understanding of how variables work in this powerful programming language. Remember to follow these best practices and tips when working with variables in your C++ code. If you have any questions or want to see more C++ content, let me know in the comments below. Don't forget to like and subscribe to MyCodingDays for more programming tutorials, and until the next one, happy coding and take care.